Welcome to mathematics class. I am Julia Alalibo, and today we'll be studying the theme numbers and numeration. And our topic for today is whole numbers part 1. The content of our lesson includes number systems, converting numbers from base 10 to other bases and vice versa, and solving questions on number bases. By the end of the lesson, I expect that you should be able to do each and every one of these objectives. So, number systems. What are number systems? This refers to different ways of writing or using the same numbers. For instance, we write 1 in Arabic as 1, which is the normal or which is the standard which we use. And then in Roman numerals, we write 1 as I. So this is a number system, and this Roman numeral is also a number system. We write 2 as 2 in Arabic, but in Roman numerals it's written as I. So these are number systems, different ways of writing or using the same numbers. Now, traditionally, we count like this: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we go back to 10 and continue on to 11, 20, and so on. So this is called the base 10 system or the denary system. The base 10 system or denary system. Now, every number has its place value. For instance, 3,829. From fundamental mathematics, we know that the place values are units or ones. Then we have tens, hundreds, thousands, tens of thousands, and so on. So each number has its unique place value. So 3,829, this 9 is the units, 2 is the tens, 8 is the hundreds, while 3 is the thousands. So if we are to expand 3,829 to read as 3 thousands, 8 hundreds, 2 tens, and 9 units. So now putting this in figures, we have 3 times thousands. We have 8 times hundreds, 2 times 10, and 9 times 1. That is units. Now we can convert the thousands and the hundreds and the tens and the ones to powers of 10. So 1,000, if we break this down, it's actually 10 times 10 times 10. So this is equal to 10 raised to the power 3 because we have 3 tens. So 10 raised to the power 3. The same thing goes for 100. Breaking 100 down, we have 10 times 10. That is 10 raised to the power 2. So that's what we have here. The same thing goes for 10, and the same thing goes for 10 raised to the power 0. Note that 10 raised to the power 0 is equal to 1. Any number raised to the power 0 is 1. So 10 raised to the power 0 actually means 1. Even if it were 8 raised to the power 0, it also means 1. Any number raised to the power of 0 is 1. So when we write this out like this, 3,829, we've expanded it to look like 3 times 10 raised to the power 3 plus 8 times 10 raised to the power 2 plus 2 times 10 raised to the power 1 and 9 times 10 raised to the power 0. Now, this number, 3,829, is based on the power of 10. As we can see, this method above is based on the powers of 10, and it is called the base 10 system. So anytime a number is written like this in such a way that it can be based on the power of 10, that number is in the base 10 system. So again, we said the traditional counting numbers are 0, 1, 2, 3, and so on up till 9. And when we get to the next number, that is 10, we don't have a single number that represents 10, unlike in the Roman numerals where X represents 10. In the Arabic numerals which we use, there's no number, single number that represents 10. So what we do is we zero out the units part and then add 1 as the tens part. So this gives us 10. The same thing when you get to 99. You do not have a single number that can represent 100. So we zero out the units part, zero out the tens part, and add 1. That is, add 1 to make this 100, and so on and so forth. So this is the base 10 system. So we said that since the number 3,829, which we saw previously, is based on the power of 10, it's in the base 10 system. So consequently, any number based on the powers of 8 would be a base 8 system number. Any number based on the powers of 2 would be called a base 2 or binary system. So for instance, if I had 3829, and rather than writing 3 times 10 raised to the power 3 plus 8 times 10 raised to the power 2 plus 2 times 10 raised to the power 1 plus 9 times 10 raised to the power 0. Now because it has 10, as we said earlier, this is now a base 10 number. But what if this number now had 8, if it was raised to the power of 8 or 2, as we have said here? That means this number will no longer be in base 10, but rather it will be a base 2 or base 8 system number. That is based on the powers of the number. So we have other bases, and they include base 3, base 4, base 5, base 6, up to base 16. Other bases of numbers. But we do not have numbers in base 1. There's no base 1 number. Now the base of a number is represented as the subscript of the number. For instance, 64/8. This is read as 64 in base 8. 954/10. This is read as 954 in base 10. 4325 is read as 432 in base 5. So when you want to say a number is in a particular base, we write it as a subscript of the actual number. So for instance, 54 in base 6 will be written as 54/6. This is 54 in base 6. So here we have 5, 4, 6, 7. Now for a number in the denary system or in the base 10 system, we have our units, we have the tens, the hundreds, and then we have the thousands. Now the units are the ones, the tens are the tens, the hundred are the hundreds, and the thousands are the thousands. This is for a base 10 number or a base 10 number system. Now for this 546, we can see that it's in base 7, not base 10. So in this point where we have the units for base 10, it's still going to be a 1. Let's call this base 7. It's going to be a 1. But in this 10th unit, it's not going to be tens, but it's going to be the sevens. The sevens. So we have 7 here. And for this 100, where we have 100 in base 10, for base 7, it will be the 49s. The 49s. We got 49 by multiplying 7 times 7. To get the next number here, we simply multiply 49 by 7. So what will be here is actually 49 times 7. And so on. What we get here, for the next column, is going to be 49 times 7 times 7. So to expand 5, 4, 6, 7, we have 5 49s. Let's write this here. This is 5, 4, 6. So we have 5 49s, which is what we have here, 4 sevens, and 6 units. So we can expand this as 5 times 49 plus 4 times 7 plus 6 times 1. And writing this in the indices form, this is 5 times 7 raised to the power 2, because 49 is 7 times 7. So this is 7 raised to the power 2 plus 4 times 7 raised to the power 1 plus 6 times 7 raised to the power 0. You can see that the number 546 is based on the number 7. So this is actually a number in base 7. It is a way of expanding a number in base 7. Another example here, we have 4325. 4325. And this is a base 5 number. So let's do the same for base 5. For base 5, we have the ones. The next number we have is the 5s. And then we have the 25s. The 25s. And here we have 432. 432. If we want to go on and on here, the next one will be 125, which is as a result of 25 times 5, and so on. That's how it increases. So this is actually 4 25s. We have 3 5s, and then 2 units. So we can expand this. This is 4 times 25 plus 3 times 5 plus 2 times 1. And writing it in the indices form, it is 4 times 5 raised to the power 2 plus 3 times 5 raised to the power 1 plus 2 times 5 raised to the power 0. This is how to expand a number based on its base. Okay, now number bases and the numbers included. For base 10, we have the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. A number in base 9 will only have 0, 1, 2, 3, 4, 5, 6, 7, 8. It will not have 9. A number in base 8 will have 0 up to 7, but it will not have the number 8 in it. It may have any of these numbers, but it will not have the number 8. The same thing goes for 7. It spans from 0 to 6. There is no number 7 in it because it's a base 7 number. For base 6, we have 0 to 5 and it stops at 5. There is no 6 in a base 6 number. And the same goes for base 5. It stops at 4. There is no 5. For base 4, it all stops at 3. For base 3, we have 0, 1, and 2. And a number in base 2 has only 2 numbers, 0 and 1. So if I say this, 5, 4, 6. 6. Now we have 546 in base 6. This is incorrect because a number in base 6 cannot have the number 6 in it. Or if I write something like this, 9, 8, 2, 1, and I say this is a base 9 number. This is incorrect because a number in base 9 cannot have the number 9 in it. So these are just a few guidelines to know if you are correct when solving a question based on number systems. Base 2 has just 0 and 1. So a base 2 number will look like this. Maybe 1, 0, 1, 1, 1, 2. This is a number in base 2. A base 2 number cannot be 1, 0, 1, 1, 2, 3. And then we write base 2. This is incorrect and impossible. Now, an example here says, expand the following numbers in the powers of their bases. Now we have 2, 3, 5, 6. To expand this, we simply denote 5 with 0, 1, and then 2. So expanding this will be equal to 2, this is a 2, times the base 6 times 6 raised to the power 2 plus 3 times 6 raised to the power 1 plus then 5 times 6 raised to the power 0. This is it. Expanding it in the powers of its base. 2, 3, 5 in the powers of its base is this. Now the next one is 5, 4, 7. Expand it in the power of its base. Its base is 7. So we have 0 here and we have 1 here. So this is simply 5 times 7 raised to the power 1 plus 4 times 7 raised to the power 0. Quite simple. Now for the fourth one, 3, 4, 8, 7 in base 9. This is equal to, we can denote this 1, 2, and 3. 3 times 9 raised to the power 3 plus 5 times 9 raised to the power 2 plus 8 times 9 raised to the power 1 plus 7 times 9 raised to the power of 0. And finally, we have 1, 1, 0, 0, 1, 2. Expanding this in the power of its base. We have 0, 1, 2, 3, 4. So this is equal to 1 times the first one times 2 raised to the power 4 plus the second one times 2, which is its base, raised to the power 3 plus 0 times 2 raised to the power 2 plus 0 times 2 raised to the power 1, and then finally plus 1 times 2 raised to the power 0. So this is it, expanding each and every one of its numbers in the power of their bases. Now, converting from base 10 to other bases, since we know that base 10 is the traditional base that is used, it is the most used number system. So we can convert from base 10 to other number-based systems. So to convert from base 10 to other bases, the first thing we do is we divide the number by the desired base. So let's say we have 989 in base 10, and we are asked to convert this number to base 3. The first step says we divide the given number 989 by base 3, that is the desired base, and then we write down the answer with the remainder. If there is any remainder, we write it down. If there is no remainder, we write down 0. The next step is to continue repeating this division until 0 is reached. We continue repeating the division until we reach the number 0. And the fourth step is the answer, that is the converted answer, is the remainders read from the bottom up. Remember, we said we always write down the remainder here. So after writing down the remainders from each division, we take it from the bottom upwards, and that gives us the answer in the new base. Let's look at an example to explain what we are talking about. Now, an example here says, convert 8410 to base 2. The first step is to divide 84 by the desired base 2. So this is what we do. We have 84, long division, dividing it by 2. And we put another column here for the remainders. Let's denote that as R. So the first step is to divide 84 by the desired base 2. 84 divided by 2 gives 42 without any remainder. The remainder is 0, so we write down 0. The next step is to continue this division until we get to a point where we get 0 here. So we still divide by 2. We don't change the base number. So divide 42 by 2. This gives 21 without any remainder. So we write down 0. Still dividing by 2. This gives 21 divided by 2 gives us 10. And there's a remainder here because 10 times 2 is 20. So remainder 1. Divide again by 2. 10 divided by 2 gives 5. Remainder 0. Divide 5 by 2 again. 5 divided by 2 gives 2, remainder 1. And then 2 divides 2 again to give 1, remainder 0. Now the third step was to continue until we get 0 on this column, not on this column, but on this column. So we still divide by 2. So 2 divided by 1 gives 0, remainder 1. And this is the end of the division. Now the final step is to write out the remainders from the bottom to the top. So from the bottom, the first number we have is 1, 0, 1, 0, 1, 0, 0. So we write down 2 here. So we have converted the number 84 to base 2, which is what we have here. 8410 is equal to 10101002. Another example, convert 8410 to base 5. Now, 8410, this is a base 10 number. We want to convert it to base 5. Now, what we do, as per the steps, we divide 84 by the desired base, 5. So we have 84 divided by 5. And remember to write down your remainder column. So 84 divided by 5 gives 16, remainder 4. 16 divided by 5 gives 3, remainder 1. And 5 divided by 3 cannot go. So 3 divided by 5 cannot actually go. So this is actually 0, remainder 3. So what we do next is to write down the answer from the bottom to the top. So this is 3, 1, 4, 5. So converting 8410 to base 5 is 3, 1, 4, 5. And remember, as we said earlier, in a particular base number, the numbers included in a number system. For instance, for a base 5 number, the only numbers included are 0, 1, 2, 3, and 4. 5 cannot be included. Look at our answer. There is no 5. This is 3, 1, 4, 5. There can be a 0, there can be a 1, there can be a 2, there can be a 3, there can be a 4, but there can be no 5. So our answer is correct. This is 3, 1, 4, 5. 8410 in base 5. Now another example here. Convert 54310 to base 6. The same rule applies. We divide 543 by the desired base, which is 6. Continue the division until we get 0, and then write the answer, that is the remainders, from the bottom to the top. So 543 divided by 6. Remember your remainder column. 543 divided by 6 gives 90, remainder 3. 6 here, 90 divided by 6 gives 15, remainder 0. 6 again, 15 divided by 6 gives 2, remainder 3. And then 2 divided by 6 cannot go, so it's 0, remainder this number 2. Now the answer is the remainders written from the bottom to the top. So this is 23036. 543 in base 10 is 23036. Now, just as we have converted from base 10 to other base systems, we can also convert from other base systems to base 10. So there are two methods of converting from a number in any base to base 10. Say you have a number in base 8 or base 2 or any other base, and you're asked to convert it to base 10. There are two methods that can be used. The first is the method of repeated multiplication, while the second is by expanding the numbers to the powers of its base, not the desired base. Now, the desired base is 10, but the second method is by expanding the numbers to the powers of its base. That is the original base of the number, not 10. Now, let's look at an example to illustrate these two methods of converting from any base to base 10. Example 1, convert 5546 to base 10. Now, by method of repeated multiplication, this is what we do. We take the first number here, 5, and multiply it by 6. Remember, this is a base 6 number. So we multiply 5 times 6. 5 is actually this first number here. This gives 30. We add the next number, 5. So 30 plus 5 gives 35. So we multiply 35 by 6. That is the base of the number. 35 times 6 gives 210. We add the next number, which is 4. So 210 plus 4 is equal to 214. There is no other number after 4. 4 is the last number, so we stop here. So converting 5546 to base 10 is 214 10. This is method of repeated multiplication. Method of repeated multiplication. Now, the next method is by expanding the number to the power of its base. We are still using the same number, 546 to base 10, but by the method of expansion. So this is 554 in base 6. So we put the 0 denotation on 4, and here we put 1, while here we put 2. If it goes on, we put 3, 4, 5, and so on. So what we do is, we have 5, which is the first number 5, times the base 6 raised to the power 2. You can put this in a bracket. The next number is 5. We multiply this by 6, which is the base, and we raise 6 to the power 1. And then the next step is 4 times still that same base, 6 raised to the power 0. And then we do the arithmetic. 6 times 6 is 36. 5 times 36 gives 180. 5 times 6 gives 30. While 4 times, remember, 6 raised to the power 0 is 1. So 4 times 1 gives 4. So 180 plus 30 plus 4 is actually 214. So 5546 is equal to 214.10. You can see that both answers are the same. This is by method of expansion. So you just suit yourself. Whatever method is easier for you, you use that method whenever you want to convert from any other base to base 10. One more example. Convert 10234 to base 10. We are going to use the method of repeated multiplication. No, we are going to use the method of expansion. So this is 10234. So we assign the numbers 0, 1, 2, and 3. By expansion, we have 1 times 4 raised to the power 3, which is what we have here. The next number is 0. 0 times 4. 4 is the base of the number. raised to the power 2 plus 2 times 4 raised to the power 1 plus 3 times 4 raised to the power 0. Now we do the simple arithmetic. 4 times 4 times 4. This is 1 times 4. 4 times 4 times 4 is equal to 64. So we have 64 here because 1 times 64 is 64. Now 4 times 4 is 16, but 16 times 0 is 0. So we just write down 0. This is 4 raised to the power 1. So 2 times 4 is 8. And any number raised to the power 0 is 1. So this is 3 times 1, and this is 3. So we add them up. 64 plus 0 plus 8 plus 3 gives 75. So 10234 is equal to 7510. That is converting from base 4 to base 10. Now this brings us to the end of our lesson for today. We said the most common number system is the base 10 system. That is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Then we have 10, 11, and so on. Other systems can be used to represent a number. They include the base 2 or the binary system, the base 3, base 4, etc. That is 5, 6, base 10, base 16. And a number can be converted from base 10 to another base by repeated division, while a number can be converted to base 10 by repeated multiplication method or the expansion method. Now before we go, let's look at a few test questions. Test question 1. Convert 9, 5, 4, 10 to base 9. This is 954 10 to base 9. To convert from base 10 to any other base, we use the method of repeated division. The first step, divide by the desired base, and the desired base is base 9. So let's do this together. We have 954. Going to divide this by 9, and not forgetting our remainder column. So 959 divided by 9. Let's take the first number. 9 divided by 9 gives 1, and 9 divided by 54 gives 6. So our tens place is 0, while this is 6. So 954 divided by 9 is 106, remainder 0. Again, divide 106 by 9. Taking 10 first. 10 divided by 9 is 1, remainder 1. 16 divided by 9 is 1, remainder 7. Now dividing 11 by 9 also. This is 1, remainder 2. And then dividing 1 by 9, it's 0, remainder 1. Now, as we said, the answer is the remainder column taken from the bottom to the top. So this is 1, 2, 7, 0, and we are converting to base 9. Right, 9 here. So option A is incorrect. Option B is incorrect. There's no base here. Option C is also incorrect, and the correct option is option D, 12709. Test question 2. Convert 1001112 to base 10. You can use the method of repeated multiplication or of repeated multiplication. So the first digit is 1. So we have 1 times 2. That is the base of the number. This gives 2. Plus, the next number is 0. So write down 0, bring it down. 2 plus 0 is equal to 2. We multiply this number by the base, which is 2. 2 times 2 gives 4. Plus, the next number is 0. So plus 0. 4 plus 0 is equal to 4. And 4 times 2 is equal to 8. Plus, the next number here is 1. So 8 plus 1, this gives 9. And 9 times 2 is 18. Plus, the next number is 1 again. So write down 1. You bring it down here. This gives 19. multiply 19 by 2 to give 38. And then the last number is 1. So 1, bring it down, equal to 39. And that is the last number. So this is where we stop, 39. So converting 100,111 to base 2 is equal to 3910. And that is option C. So the correct option is option C. You can also try the method of expansion to check if this answer will also be gotten, 3910. This brings us to the end of our lesson for today. I hope you understood each and every concept. Do have a nice time. Thank you.
If you enjoyed this video, hit the like button, drop a comment, and subscribe to our channel. You can also turn on notifications to stay updated on new videos on this channel. This Brain Friend video was brought to you by Synforest. For more of these amazing e-learning videos, get your copy of Brain Friend. With more than 1,000 e-learning videos, over 74,000 test items in more than 40 subjects, a career counseling guide, and many other amazing features, BrainFriend remains your foremost e-learning and exam preparatory software. BrainFriend. Learn better, make excellent grades.